Welcome to this lesson on surviving Agile scenario traps. The PMP exam doesn't just test your knowledge of Agile practices, it tests your ability to think with an Agile mindset. Many exam questions include answer choices that sound reasonable from a traditional project management perspective, but they actually violate Agile values. These are the hidden traps that many PMP candidates fall into. In this lesson, we'll explore 4 common Agile scenario traps. The first is the rigid contract trap, where candidates focus on protecting contracts instead of collaborating with customers to maximize value. The second is the missing role trap, where teams compensate for an absent product owner instead of restoring the proper Agile roles and responsibilities. The third is the velocity trap, where project success is judged by speed and metrics instead of customer value and business outcomes. The fourth is the venting trap, where retrospectives become complaint sessions rather than opportunities for continuous improvement. Although these scenarios look different, they all test the same Agile principle. Successful Agile teams collaborate with stakeholders, adapt to change, focus on delivering customer value, and continuously improve. Whenever you face an Agile scenario in the PMP exam, don't ask, "Which process should I follow?" Instead, ask, "Which option best delivers customer value while promoting collaboration, adaptability, and continuous improvement?" That simple mindset will help you identify the traditional traps and confidently choose the Agile answer. Following are 5 questions to test your knowledge.
Imagine a high-performance engine running at maximum redline. It's perfectly tuned, smoothly humming, and executing every internal process flawlessly. But because it is detached from the drive shaft, it produces zero forward momentum. This is the exact paradox many professional teams face. They consistently hit every velocity commitment on paper, while failing in reality to deliver the outcomes stakeholders actually need. This failure happens because market expectations and competitive shifts often evolve much faster than the items sitting in a static product backlog. This chart shows a common professional misconception. While the green line shows velocity climbing, creating a sense of progress, the blue line representing customer satisfaction is in a state of collapse. This occurs when we treat output volume as being equivalent to delivered business value. Maintaining high velocity in the wrong direction is not a success, it is a highly optimized project failure. Standard meeting routines and delivery schedules provide the structure for work, but they do not inherently generate value. The framework is designed to function as a strict empirical feedback engine, engineered specifically to optimize value through continuous adaptation. When this engine produces speed without value, it indicates a mechanical failure. Specific feedback loops within the system have been compromised or bypassed, disconnecting the engine from the drive shaft. The foundational axiom of Agile framework mechanics is that delivering measurable value always takes priority over executing a rigid, predefined plan. To achieve this, the engine processes data through 4 basic nodes. We have the backlog serving as input, the sprint driving execution, the review facilitating inspection, and the retrospective ensuring adaptation. This engine only works if the connections between these nodes remain intact and interactive, allowing data to flow clockwise through the loop. In practice, external shocks, such as regulatory shifts or the loss of leadership, frequently sever these connections. When the system is shocked, many managers default to legacy instincts, attempting to lock down the scope or enforce rigid contracts to regain a sense of control. To see how the system is actually designed to survive, we will run this Agile engine through 4 real-world stress tests derived from PMP and Agile certification scenarios. Mastering these mechanics requires knowing exactly how the engine processes disruption to keep the project on track. Let's initiate the first stress test by zooming into the backlog node. This is the CRM Scope Swap scenario. Midway through a sprint, a customer requests replacing a low-priority feature with an AI-powered capability of similar effort. The procurement manager objects, arguing that the statement of work defines a static, unalterable scope. The traditional instinct is to reject the request to protect the legally approved SOW. This approach fails the core objective of the engine. You cannot optimize for value if you are forcing the delivery of features that have already become obsolete. The solution is straightforward. Since the new feature requires similar effort, capacity and budget remain protected. As shown in answer B, the correct action is to reprioritize the backlog and swap items immediately. Many teams believe that minor Agile changes require formal, complex contract change control boards, which creates a significant process bottleneck. In reality, Agile contracts are boundaries for capacity. They are not intended to force the delivery of low-value work. Next, we move the stress test to the execution node. Here, we have an absent product owner. The PO has missed 3 consecutive sprint reviews, causing a total loss of the feedback loop. Customer complaints are rising because the features being built no longer align with business needs. Without active navigation, developers end up executing based on outdated priorities, causing the product to drift away from the market. A common trap is asking the development team to take over strategic product prioritization in the product owner's absence. However, the Scrum Master has a specific operational duty, removing systemic bottlenecks. The mechanical fix is answer C. They must escalate to leadership to restore active participation. A team without a product owner is a fast engine without a steering wheel. The system stalls when this role goes offline. Now we apply a jarring stress test to the sprint node, a mid-cycle regulatory shock regarding cybersecurity requirements. In this scenario, a regulator introduces mandatory rules midway through a 5G platform development. The team is arguing over whether they can alter the current sprint commitment. Incorrect responses usually involve either ignoring the law to protect the sprint or immediately canceling the entire sprint in a panic. Sprint cancellation is a last resort, reserved only for when the core sprint goal becomes completely obsolete. The correct Agile protocol is a collaborative impact assessment. As answer B demonstrates, the team must adjust priorities mid-sprint to accommodate the mandate while preserving the original goal. The framework is specifically designed to absorb and adapt to external shocks in real time, preventing the cycle from breaking. We now move to the final phase of the Agile engine, the inspection and adaptation nodes. The paradox of velocity without value is usually rooted in a failure at the sprint review stage. This failure happens when teams treat sprint reviews as passive feature demonstrations or one-way status reports. This illustration shows the interactive board and collaborative dialogue that define a true sprint review. This ceremony is the primary steering mechanism of the framework. The mechanical requirement here is that direct stakeholder feedback must dynamically reshape the future product backlog. If the backlog doesn't change after a sprint review, the feedback loop is effectively broken, and the team is likely building the wrong product. Highly optimized velocity cannot compensate for an incorrect product roadmap. The review ensures that every unit of speed is accurately aimed at value. We conclude at the final node of the engine, the retrospective. Consider the retro inertia scenario. A team observes rising defects, but admits no action items are ever executed because they rush directly into the next sprint without planning improvements. Storing process insights in a legacy lessons learned folder where they are never reviewed is a failure of empiricism. Continuous improvement in Agile must be empirical, measurable, and actionable. The Scrum Master must guide the team to select 1 or 2 small, realistic process improvements and incorporate them directly into the next sprint backlog, as shown in answer C. Using a structured visualization board like this helps the team move from vague complaints to hard commitments. This integrated schematic shows the complete 4-node cycle, where every disruption is processed and converted into a value-based output. The technical rules of the framework serve a singular function, maintaining the integrity of this continuous feedback loop against organizational friction. Protecting the cycle ensures the project remains tethered to actual business results.